Hello, and welcome to this video about graphs of linear functions. Today we'll explore what happens to a graph when the slope or y-intercept is changed. Specifically, we'll examine what happens when these constants are positive or negative values, as well as when the slope is a fractional value. Before we get started, let's review a few things. A linear function is a function that is a straight line when graphed. Its equation can be written in slope-intercept form, y equals mx plus b. The variable m represents the slope, which measures the direction and steepness of the line graphed. The slope is found by calculating the rise over run, which is the change in y-coordinates divided by the change in x-coordinates. The variable b represents the y-intercept, the point where the graph of a line intersects the y-axis. Let's take a look at an example together. Consider the equation y equals 2x plus 1. Let's start by finding the y-intercept. Looking at the graph, we can see that the line crosses through the y-axis at 1, or 0, 1. Our equation reflects this because the value of b is 1. Now let's examine the slope. From the y-intercept, the second point is found by moving in a vertical direction, the rise, and then a horizontal direction, the run. From the y-intercept, move 2 units up and 1 unit to the right. Therefore, our slope, m, equals 2 over 1, which equals 2. Our equation reflects this because the value for m is 2. Now let's consider how the graph changes if we change the slope. Consider the equation y equals negative 2x plus 1. It is the same as our last equation, except now our value for slope is a negative number. Negative 2 over 1, or negative 2. Let's examine the new graph for this equation and compare it to the previous graph. As you can see, the line in this graph moves in an opposite direction as compared to the first graph. Since the slope m is negative, the line moves in a negative direction. The y-intercept b is 1, which is the same as our previous graph. The line crosses through the y-axis at 1, or 0, 1. Our equation reflects this because the value for b is also 1. From the y-intercept, 0, 1, plot the second point on the line by moving in a vertical direction, rise, and then a horizontal direction, run. Because the numerator of the slope is negative 2, move 2 units down from the y-intercept. From there, move 1 unit to the right as indicated by the slope's denominator 1. Note that a positive rise moves up and a negative rise moves down. A positive run moves right and a negative run moves left. Let's examine another graph that changes the slope again. The equation for this graph is y equals negative 2/3 x plus 1. This time our slope is a fraction, negative 2/3. Since the value of m is negative, this line moves in a negative direction. Our y-intercept value has not changed, so we still see that the line crosses through the y-axis at 1, or 0, 1. Our equation reflects this because the value for b is also 1. Notice how the steepness of this line is different. Compared to the last two graphs, this line is less steep. Let's understand why that is. From the y-intercept 0, 1, plot the second point on the line by moving in a vertical direction, rise, and then a horizontal direction, run. Since m equals negative 2/3, move 2 units down and 3 units to the right. From this example, we can see that the larger the slope's denominator is, the less steep the line will be. What if the value of the slope m was 0? Consider the equation y equals 0x plus 1. In this case, there is no rise or run because the value of m equals 0. There is a y-intercept at 1, or 0, 1. When graphed, a line with a slope of 0 is a horizontal line, as shown. Based on this information, what would the graph for y equals 0x plus 5 look like? It would look like a horizontal line passing through the y-intercept of 5, or 0, 5. What would the graph for y equals 0x plus 0 look like? That's right, a horizontal line passing through the y-intercept of 0, or 0, 0. Now that we know what happens to the graph of a linear function when we change slope, let's examine what happens when we change the y-intercept. Consider the graph for the equation y equals 2x minus 1. Recall that the first equation and graph we looked at, y equals 2x plus 1. The only difference in this equation is that the y-intercept, b, is a negative value, negative 1. As a result, we see on our graph that the line intersects the y-axis at negative 1, or 0, negative 1. From the y-intercept 0, negative 1, the second point on the line is plotted by moving in a vertical direction, rise, and then a horizontal direction, run. Since m equals 2 over 1, move 2 units up and 1 unit over to the right. Therefore, our slope, m, equals 2 over 1, which equals 2. What do you think the graph would look like for a linear equation with a y-intercept value of 0? Let's take a look. Consider the equation y equals 2x plus 0, which can also be written as y equals 2x. As you can see, the line passes through the y-axis at the origin, or 0. Since the y-intercept b is 0, this makes sense. The slope m is 2 over 1. From the origin, move 2 units up, rise, and 1 unit over, run, to reach the next point on the line. What if the y-intercept is a fraction? Consider the equation y equals 2x plus 1/2. In this case, we see the line passes through the y-axis halfway between 0 and 1 at 1/2, or 0, 1/2. If the y-intercept is a fractional value, then it will pass through the y-axis at the fractional value it represents. The slope m is 2 over 1. From 0, 1/2, move 2 units up, rise, and 1 unit over, run, to reach the next point, 1, 2.5. We're going to take a look at one final example. This time you're going to try it on your own. The next graph will combine everything we've talked about so far. It's a little more challenging, but I know you can handle it. I'm going to give you the equation. Once you see the equation, pause the video, draw a coordinate plane, and see if you can graph the equation yourself. When you're done, resume and we will go over the graph together. The equation I want you to graph is y equals negative 1/4 x minus 3. Now that you're ready to check your work, let's take a look at the graph together. First, let's take a look at the y-intercept b. Recall that the value for b in our formula was negative 3. That means that the line passes through the y-axis at negative 3, or 0, negative 3. Now that we've graphed our y-intercept point, let's consider the slope. The value for slope m in the formula is negative 1/4. So from the y-intercept point, we need to move down 1 unit and right 4 units. This brings us to the next point on the graph, which is 4, negative 4. Understanding how constants work helps mathematicians recognize patterns in graphs of linear functions. I hope that this video about changing constants in graphs of linear functions was helpful. Thanks for watching and happy studying.